with what is the meaning of force, right? We're going to be first talking about its definition, okay, and also its effects. So the definition of force means it is a push or a pull that can change the state of motion or shape of an object. Like here you can see the trolley is moving, like in whichever direction we push it, we're giving it a force. The drawer is pulled. If we pull something, it is going to come near us. We can also change the direction with a force. Like if ball is coming from some direction, we can apply a force and change it in another direction, right? So types of force: contact and non-contact forces. Contact forces, they require contact between objects, like pushing a trolley, okay, frictional force and other stuff. Non-contact forces like gravitational force, magnetic force, these are non-contact forces. They do not require a physical touch, right? Effects of force also we are going to be talking about today. Like it help, like force can cause change in motion, state of motion, from rest or from rest to motion. It can also change shape and size of an object, speed of an object. Alright, so all of these concepts we're going to be discussing today. Okay, let us go to our 3D models and try to understand these things in a better manner. So here students, you can see a push or a pull causing change in object's position or shape. Okay, here you can see the person is trying to pull the cow. It is pulling the cow. He is pulling the cow towards himself. Like, so the pull is a force. You can see it is producing some effect on the cow. The cow is slightly moving forward. So push or a pull are both called as forces. Now we have seen about what a pull can do. Let us see a pushing force in motion. Okay, here you can see the person is trying to push a table. The person is trying to push a table. So you can see as it is moving, it can also like change the position of an object. So both push and pull, they can cause change in a position, in the position or the shape of an object. Okay, let us talk about the effects of force, right? So here you can see it can cause motion from rest and rest from motion. Now previously the table was at rest, right? Previously the table was at rest. The boy, he started what? Pushing it. So it can cause motion from rest and rest also from motion. Like if, like for example, if a ball is traveling, now we know that every object after traveling some distance, it eventually comes to a rest position. Now what causes it? The ball is going to stop now. Here you can see it is stopping. So what causes it? The cause is frictional force. Okay, frictional force, students, happens in between, okay, the ball and the ground. Okay, if we think about friction, it always acts opposite in direction to motion. Okay, always acts opposite. Okay, it always acts opposite to the direction of motion of an object. So eventually anything which is moving will eventually come to a rest position because of frictional force. Frictional force opposes motion, right students? Now let us move forward. Let us see what other effects of force can be possible. Now force can also change the direction of moving objects. Force can also change the direction of moving object. Now let us see it from top view like this. Okay, you will see that the ball is coming towards the person and the person is going to apply a force and change the direction of the ball towards the goal post. Right, here you can see the ball is coming in a different direction and he is kicking it again by applying force in a different direction. Here you can see, let us play the model again. The ball is going to come towards south, he is kicking it towards east, right? So he applied the force which is applied, it did not it caused a change in direction of the object. The ball was going in some other direction and he kicked it to some other direction, right? Now what like lastly, it can also have a shape changing effect. It can change the shape and size of an object also. Here you can see the balloon is being pressed. right? The balloon is being pressed and you can see the balloon is changing its shape with the application of force. Okay, when force is being applied on the balloon, it is changing its shape also. So the force can cause a change in direction, change in position from rest to motion, from motion to rest, and also it can cause the shape change or size change of an object, right? Now let us discuss about balanced and unbalanced forces, very important. Alright, now let us look at a glance what are we going to be talking about in balanced and unbalanced forces. Alright, so in balanced and unbalanced forces, we're going to be learning about what is balanced force, what is unbalanced force. Balanced force is when forces that are equal in magnitude and opposite in direction, resulting in no change in the object's state of motion. Okay, when equal forces are acting from opposite direction, so they cancel each other out. The object remains in its state of rest or motion. In whichever way it was before, it will remain like that. No change in the state of motion is going to happen in case of balanced force, right? But similarly, if we apply unbalanced force, the moment unbalanced force is going to be applied, then only it is going to create a change in the position, be it rest position or be it uniform motion position. So anyways, there will be a change in the position or speed, velocity. Okay, either it is going to speed up or it is going to speed down, or is it going to change direction. So this is going to happen only when unbalanced force is required. Unbalanced force plays a huge role in Newton's first law. Okay, so we will be trying to understand this unbalanced force through our 3D models. All right. Now students, here we have two person, like they're equal in size and muscular power, as you can see, right? So fun aside, as you can see, these two people are going to be applying equal force on the table from opposite sides. Okay, and a balanced force will be applied, the table is not going to move, right? So if they both are applying a force, let's say for example, and yeah, I forgot to mention students that force is a vector quantity, okay, and the unit that we use to measure force is Newton. Okay, we use Newton. All right, let me write it again. Okay, Newton is the unit of force. All right, or we can just write capital N like this. Okay, and remember students, whenever we are writing the full, let me erase it, I made a tiny mistake here. Whenever we are writing the full name of the unit, students, and if it originates after any scientist, we write it in small letters like this. Okay, if we are writing the unit which has been derived out of the name of a scientist, we write it in small letters. If we want to write the full name, if we just want to write it in short form, it is written in capital M. Same thing with joule, like watt, unit of power, W. So if you want to write entire watt, like we have to write WATT all in small letters. If you want to write just W, the W should be written in capital letters. Same thing for Celsius, Fahrenheit, all of these unit, students, they're derived after the names of scientists. Okay. Now, so let us come back. So if 10 newtons of force, let's say, or you can say, let's say 60 newtons of force. Okay, 60 newtons of force are applied on both sides. Okay, each boy or each man is capable of producing 60 newtons. So 60 newtons is from left to right for the case of the first person and right to left in the case of the second person. Now as we discuss, students, balanced forces, in case of balanced forces, equal in magnitude and opposite in direction the forces should have. So both of them will cancel each other out and you can see the object will not move. Okay, the object is not going to move. Now Let's say for example, if both of them come to the same side now, if both of them are coming to the same side, okay, here unbalanced force happens, students, because remember, if each of them is 60, so 60 and 60 together will make 120 newtons from left to right, but there is no force from right to left. There can be some kind of friction, but it is negligible, we are not accounting for that. So this becomes an unbalanced force, and here net force will not be equal to 0, and the object's position and direction, or whatever state of rest or motion it was, it is going to now change. So in case of unbalanced forces, the net force is always going to become 0, and unbalanced force is the one only which can cause a change in state of motion or rest or direction. Okay, balanced forces is not going to affect in any manner. All right, let us do some questions on the basis of this. Okay, what is the definition of force? Very simple, very simple. A push that increases the speed of an object, a pull that reduces the speed of an object, a push or pull that can change the state of motion or shape of an object, or option D, the effect caused by the application of power. Very simple answer, students. The answer is option number C, that is a push or a pull that can change the state of motion or shape of an object. Alright, let us move forward. Now, how can force alter the shape of objects? By increasing its volume, by changing its color, by causing compression, means pressing, or expansion or expanding, or by making it heavier or lighter. Very easy question, students. By causing compression or expansion. Its volume is not going to change, only its shape is going to change because it can get compressed or expanded. Right? Now, what are the effects of force on motion? It can increase or decrease the speed and change direction. It can change color and shape. It can increase or decrease the size and change orientation, or it can only increase speed. Very simple. Again, we have discussed it. It can increase or decrease speed. Okay, position. It can change direction. Okay, shape, size, all of these things can be changed. Right, students? Now, let us have some questions regarding balanced and unbalanced forces. Now, which forces result in no change in the object state of motion? Just now, 2 minutes back, we discussed. Which forces result in no change in the object state of motion? It is balanced forces, because balanced forces cancel each other out. Whatever state of motion or rest was there in the beginning of the object, it will remain exactly the same. Right? Now, what happens when unbalanced forces are applied to an object? Again, very simple question. Okay, the object stays at rest, the object moves with a constant velocity, the object changes its state of motion, or is it none of the above? The objects change their state of motion. Okay. Another very good question here. If you push, listen very carefully, if you push a box with smaller force than the friction force of the floor, what will happen? If you are pushing a box with a force that is smaller than the frictional force, now that means the question is asking us that the frictional force is greater than the force that you are applying. What will happen? Will the box move? The box will start to move, or the box will not move? The box will disintegrate, okay, or the box will levitate? Very simple question, students. The box will not move. Why? Because you need to overcome the force of friction. That means your force should be greater than the frictional force in order to be able to successfully move the box. As long as the frictional force is greater than the force that you are applying, the box will stay in its position. It is not going to move. Okay, students? So today we discussed many questions on the topic of force. What is force? What is the effects of force? We discussed the concepts regarding balanced and unbalanced forces also. From the next session onwards, we're going to be starting with what is the first law of motion, what is inertia, very interesting topics we're going to discuss. Okay, so that's all for today, students. Have a nice day.